everyone, and thank you for attending today's webinar, Unlock the Next Wave of Genomic Discovery with NovaSeq X. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use. These are all resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking the arrows in the top right corner. If you have any questions during the webcast, you can submit them through the Q&A widget. For the best viewing experience, we recommend using a wired internet connection and closing any programs or browser sessions running in the background that could cause issues. Webinars are bandwidth intensive, so closing unnecessary browser tabs will help conserve your bandwidth. The webcast is being streamed through your computer, so there's no dial-in number. For the best audio quality, please make sure your computer speakers or headset is turned on and the volume is up so you can hear the presenters. Some networks cause slides to advance more slowly than others, so logging off your VPN is recommended. If your slides are behind, pushing F5 on your Windows keyboard or Command R on a Mac will refresh the page. You can find answers to common technical issues in the Help widget at the bottom of your screen. Now I would like to introduce our speakers, Meghan Buckley, Senior Product Marketing Manager at Illumina, and Deepthi Shankar, Senior Staff Product Marketing Manager at Illumina. Welcome.
Thank you, Sarah. So today we're really excited to cover three main areas around the NovaSeq X. First, we'll talk about features and innovations. Next, we'll talk about how to scale up your sequencing in your lab. And finally, we'll cover the onboard informatics on the instrument. First, let's talk about the innovations and features of our newest high-throughput platform. Earlier this year, we began shipping the revolutionary NovaSeq X series, our most powerful, most sustainable, and most cost-effective sequencer to date. NovaSeq X can sequence 52 billion reads per dual flow cell at a rate that's approximately 2.5 higher throughput and 2 times faster than the NovaSeq 6000. This speed enables single-day runs with turnaround times under 24 hours for some configurations. NovaSeq X is also the world's most sustainable high-throughput sequencer, with a 61% reduction in climate change impact and 90% reduction in waste. It's the only high-throughput instrument to eliminate the need for dry ice for shipping, expanding the market and improving efficiency. Also, NovaSeq X is the only high-throughput sequencer with onboard analysis and up to 5 times lossless data compression, which we'll cover in more detail shortly. These features collectively provide fast, easy, more complete, and a fully analyzed genome at our lowest cost ever. The NovaSeq X has over 40 patent applications, and it took 5 years and 1,500 scientists, engineers, developers, and designers to create. In order to achieve the desired output, speed, and cost, the NovaSeq X had to be built from the ground up with new technology. XLEAP SBS is our fastest and most robust SBS chemistry, and its stability allows for ambient shipping. We developed an ultra-high density flow cell, packing more clusters into a smaller footprint. In order to image these new flow cells, we needed an optical system that delivers increased resolution and sensitivity. And lastly, we added onboard Dragon to get from sample to result even faster. XLEAP SBS chemistry on the NovaSeq X series is built on a backbone of a novel polymerase, as well as new X-block, X-linker, and X-dyes. It generates high-quality data faster and more sustainably than ever. With our XLEAP SBS chemistry, We are observing high-quality sequencing metrics with improvements in read-to quality as well as lower error rates across multiple library types compared to the NovaSeq 6000. If we take an even closer look at that data, the vast majority of data coming off of the NovaSeq X measures at or above Q40, highlighting the accuracy of our new chemistry. In further testing, XLEAP SBS shows promising error rate and phasing and pre-phasing rates with a single 300-cycle read length. The NovaSeq X is just the beginning of our XLEAP SBS technology, and this shows that it has a lot of potential to develop even further. The NovaSeq X brings back a well-loved feature of our users with individually addressable lanes. We have 2 and 8-lane flow cell configurations, and this process has been streamlined with automated lane loading so you can spend less time figuring out if different libraries are compatible and more time on other things. One of the most exciting features to people so far is our updated packaging and shipping. The NovaSeq X series has 1/3 of the boxes and 1/10 of the weight of the NovaSeq 6000, and the single box used for NovaSeq X is smaller than any of the 3 NovaSeq 6000 boxes. With our new XLEAP, this means no more dry ice or ice packs. It means an easier, faster, and more user-friendly unpacking experience, so we can do away with the unboxing parties of the past. Ambient shipping means you can go straight from unpacking to sequencing with no thaw needed. We've also updated the packaging to be even easier to use. The kit-specific components are a solid color, while universal components will have a gradient. This makes it easier than ever to grab reagents out of your freezer without fear of thawing the wrong component. No stone was left unturned when designing this instrument to provide maximum operational efficiencies. We've added speed, flexibility, and ease of use to make high-throughput sequencing more accessible than ever. Next, let's talk about how all of these innovations can help to scale up sequencing in your lab. As our newest high-throughput instrument, the NovaSeq X sets the bar in every metric. Compared to the NovaSeq 6000, we have 2.5 times more throughput at twice the speed. The NovaSeq X series can generate up to 16 terabases of data and over 128 human whole genomes in a single run. As we've continued to build out our high-throughput sequencing portfolio over the years, we've built upon a reputation of shrinking turnaround times and lowering the cost of sequencing while also expanding the breadth of applications. NovaSeq X is no different. The applications customers can do on a high-seq X and NovaSeq 6000 are still around, but they're becoming cheaper and easier to perform. With NovaSeq X, we've added gas behind these data-intensive methods, such as whole genome sequencing, 1 million plus single cell, spatial, and multi-omic approaches. The NovaSeq X portfolio includes several instrument and kit configurations to allow for flexible batch processing and a wide breadth of applications. Currently, we have the NovaSeq X Plus instrument, which is a dual-sided instrument allowing for 2 simultaneous independent runs. Coming in the first half of next year is the NovaSeq X, which can run a single flow cell. Both instruments can run all of the flow cell configurations. For consumables, currently shipping is the 10B portfolio kit. The 10B has a similar output to the NovaSeq 6000 S4 for those familiar with that platform. Coming this quarter is the 25B, which is our highest output flow cell ever, which can generate 8 terabases of data. And additionally, we'll have our 1.5B flow cell, which has a similar output to S1 on the NovaSeq 6000. We have kits for different read lengths and outputs to provide flexibility. Our 1.5B is ideal for smaller or pilot projects and fastest turnaround times, and it's a great entry point into high-throughput sequencing. The 8-lane 10B allows flexibility with multi-project runs and decreased turnaround times. And our 25B flow cell can sequence 3 times more samples than the 6000 in about 2 days. This opens up deeper sequencing and highest discovery power. With the 25B flow cell, the NovaSeq X can sequence 15 to 20,000 human whole genomes a year. And running whole genome sequencing is the most comprehensive option for variant analysis. Despite being the most comprehensive, whole genome sequencing can be expensive and cost prohibitive. This pushes more to run whole exome panels. The NovaSeq X is shrinking the gap between whole genome sequencing and whole exome sequencing, making whole genome sequencing more accessible than ever. And with whole genome sequencing, we can gather the most data possible from each sample and minimize bias. If we look at whole genome performance on the NovaSeq X, we're observing similar, if not better, metrics than the NovaSeq 6000 across the board. Our short-read whole genome sequencing with DRAGON addresses many challenging variants, and Illumina Complete Long-Read Prep expands that further to the small percentage of challenging genic regions. Currently, we have our whole genome product that supplements short-read whole genome for uncovering challenging variants. We will also have our targeted panel to access known challenging regions. The Illumina Complete Long-Read Preps are coupled with our short-read whole genome sequencing to enable short and long-read sequencing on a single platform. This quarter, we'll be making long reads even more accessible by adding the enrichment product to the portfolio. The NovaSeq X benefits extend to many applications. Single-cell studies continue to require increased sequencing output. More complex tissues, cells, or modalities are now even more accessible on the NovaSeq X. The studies highlighted here can be enabled on a single run on the NovaSeq X flow cell output. With a 25B, we can perform genome-scale perturb-seq, analyzing 2 million single cells in about 48 hours. These studies that may have once taken several runs over weeks can now be accessed with a single run on the NovaSeq X. When we look at single-cell data on the NovaSeq X, we see extremely high concordance with the NovaSeq 6000. With the NovaSeq X, we can run RNA applications like gene expression profiling, mutational profiling, and even cell-free RNA biomarker discovery projects on a single flow cell in 2 days or less. NovaSeq X also shows high concordance with NovaSeq 6000 in RNA sequencing of different cell lines. Additionally, the NovaSeq X is making multi-omic approaches more accessible than ever. From coupling ATAC-seq with RNA-seq to using whole genome methylation to characterize stem cells, we can pair more applications at a lower cost than ever before for the deepest insights. The higher output, speed, and reduced costs on the NovaSeq X enables larger projects and deeper sequencing, driving more powerful studies than ever before. Next, I will pass it over to Deepthi to talk about onboard informatics on the NovaSeq X.
Thank you, Megan. That was a great overview of NovaSeq X series. Let's look at another great benefit of the NovaSeq X series, which is onboard secondary analysis with DRAGON. So what exactly is DRAGON? DRAGON, or Dynamic Read Analysis for Genomics, is a collection of hardware-accelerated bioinformatics pipelines used for secondary analysis. This happens right after sequencing. DRAGON takes reads and creates variants or counts depending on the application. And DRAGON output feeds directly into tertiary analysis where genetic data is interpreted. DRAGON has been designed to be our most accurate, comprehensive, and efficient secondary analysis solution to date. NovaSeq X is one of the first high-throughput instruments ever to have DRAGON analysis on board. This sets a new standard in operational simplicity where you can get secondary analysis output directly from the sequencer. With onboard DRAGON, you can simplify your operations with faster, easier data analysis in an easy-to-use graphical interface. DRAGON onboard NovaSeq X is the most powerful DRAGON implementation ever. It's optimized for NovaSeq X using multiple FPGA cards on the instrument. So you have the most powerful DRAGON on the most powerful instrument, enabling you to scale your studies as never before. DRAGON onboard comes with 4x reduction in manual touch points as compared to standalone solutions, faster data transfers, and the ability to stream to our cloud platform, Illumina Connected Analytics, for large-scale data management, analysis, and aggregation. And it's highly accurate, so you can analyze the data with confidence. DRAGON generates high-quality variants directly onboard NovaSeq X, leveraging advancements like multi-genome graph and machine learning to generate high-quality results. DRAGON onboard NovaSeq X comes with hardware and license included, so you don't have to pay for analysis that you do onboard the sequencer. It comes with DRAGON Original Read Archive, ORA compression, which is a lossless compression that reduces FASTQ file size, storage, and energy costs by up to 80%, all without loss of data. With DRAGON onboard the NovaSeq X series, you can sequence and analyze your way at scale. NovaSeq X series comes with some of the most popular DRAGON pipelines integrated on board. These were selected based on the relevance to high-throughput customers, and it supports multiple analysis on a single flow cell. The 4 main application pipelines available now include DRAGON BCL Convert for fast, efficient conversion with QC reports and ORA compression, DRAGON RNA with RNA expression quantification and differential expression for our molecular and cell biology research community, DRAGON enrichment with small variant calling, copy number variant calling, and structural variant calling for germline and somatic enrichment samples, for example, whole exome or targeted panels, and DRAGON germline with comprehensive whole genome analysis, including small variants, structural variants, CNV, and others. And we continue to invest in building more analysis pipelines for DRAGON onboard NovaSeq X series. DRAGON onboard delivers speed, flexibility, and a high degree of operational efficiency, accelerating your sequencing workflow turnaround. On the slide here, you can see how with Dragon on board, you can do back-to-back sequencing, essentially doing your analysis during the wash and prep time between your runs. This is assuming a 2-hour wash time at the end of run 1, 30 minutes of hands-on run setup time, and 4 hours of cluster generation for a total of 6.5 hours. On the left, we have highlighted the analysis pipelines that can be completed within the wash and prep time, enabling that back-to-back sequencing. These include BCL convert, Dragon RNA, Dragon enrichment, Dragon germline with MapAlign, etc. And on the right-hand side, you will see that there are a few pipelines that are computationally very intensive, like Dragon germline with small variant calling and Dragon germline with all variant callers enabled. And these require additional wait time between the runs. However, they are still really efficient analysis. The NovaSeq X series software ecosystem tech node has more details on the run times and is available to download for free. To highlight, BCL convert on average takes about 1.5 hours, and germline with all variant callers enabled for 4830X whole genomes takes about 7.5 hours. And these are the two ends of the spectrum here. To summarize, you get faster and easier data analysis with Dragon onboard NovaSeq X series. Illumina has been innovating on our analysis pipelines continuously over the years, and we continue to do so to enable us to provide highly accurate results. The plot here on the right shows the improvements in Dragon that allow for a comprehensive coverage of the genome with an overall accuracy of 99.83% for small variant calling, and that's based on the Precision FDA V2 True Challenge benchmarking data. And that same Dragon with award-winning accuracy is available on board the NovaSeq X series. Dragon on board NovaSeq X series enables remarkable cost efficiency. As mentioned earlier, Dragon on board hardware and license is included with the NovaSeq X series. You can reduce data storage, transfer, and retrieval costs with up to 5x lossless Aura compression. And if you run Dragon on board at maximum capacity, your cost savings add up to $1 million in over 5 years for NovaSeq X and $1.7 million for NovaSeq X Plus. This is assuming FASTQ files are archived 30 days after cloud upload and a throughput of 10,000 whole genomes per year for NovaSeq X and 20,000 whole genomes per year for NovaSeq X Plus. And this is the combined savings of Dragon hardware, license, and cloud storage over 5 years. All right, so let's talk about the specs and features of Dragon onboard NovaSeq X series. There are 2 FPGAs that support Dragon onboard NovaSeq X and 4 FPGAs for Dragon onboard NovaSeq X Plus. We anticipate doing 1 update per year for the onboard pipelines and 2 per year for the cloud workflows. As mentioned, there are 4 onboard pipelines available now, and you can do these 4 analysis per flow cell simultaneously. That is, the 3 application pipelines and BCL convert. One thing to note is the Dragon onboard is not the same as Dragon server. It does not offer command line access, but it has a great graphical user interface. Also, in terms of data compatibility, it can only process data that's generated on board the sequencer and the data that stays on the sequencer. So if data is removed from the sequencer, you will not be able to process that data with Dragon on board. So if you want to reanalyze the data after a few weeks, you might want some sort of redundancy in the system to do that reanalysis. There are a number of features and settings you can fine-tune with Dragon on board, like enabling different variant callers, targeted callers, specifying reference genomes, etc. But it's not the full degree of customizability that you get with Dragon server or with Dragon on Illumina connected analytics. The Aura compression that compresses FASTQ files up to 5-fold is enabled by default in Dragon on board, which is a great value add. NovaSeq X series also fully integrates with Illumina connected software from lab management, run planning, and run management to data analysis and data interpretation, enabling you to run sequencing your way. The NovaSeq X series software ecosystem tech note that we mentioned earlier covers this in detail. We have discussed the key features of Dragon Onboard NovaSeq X series. Now, let's look at a few scenarios and see how your organization may benefit from Onboard Dragon. If you're a service provider or a commercial research organization looking to expand menu, you can give customers more than just reads. You can give them the most accurate variants with integrated onboard analysis. If you look at the onboard analysis pipeline here, you can get seamless automated FASTQ generation, or you can get variant calls, all with a quick turnaround time and with no extra cost or equipment. In fact, you can save on the data storage cost with up to 5x data compression on board. And you can streamline your operations with a single user touchpoint to variant call files. For clinical research institutes, the Dragon Onboard workflow provides a highly accurate and comprehensive analysis with coverage of different variant types, including SNPs, indels, copy number variants, structural variants, short tandem repeats, etc., enabling you to maximize your findings. These variants can be directly imported into your tertiary analysis solution of choice. And you get this with an intuitive user interface and quick turnaround time. If you're trying to lower cloud costs and maximize throughput, then you can leverage Dragon Onboard workflows to get variants without additional cost. NovaSeq X significantly increases throughput and scalability for large-scale genomic projects. Previously, you would have had to sequence and analyze separately. NovaSeq X not only increases your sequencing throughput, but also seamlessly integrates secondary analysis in your workflow with no additional cost and integrates with downstream cloud analysis and data aggregation, thus increasing your overall throughput and operational cost savings. Before we wrap up, I want to highlight a couple of quotes from our customers. This is from Lachlan Morrison, a senior technical officer at Biomolecular Resource Facility at the Australian National University. He said, "One of the big benefits I can see in the new Dragon Onboard analysis on the NovaSeq X Plus is the considerable reduction in file size, now being compressed to approximately 1/5 of what would be a traditional file, which allows us to run more projects at population scale." And we have another quote from Tiffany Chu, who's a bioinformatics research associate at Sigmatic. It says, "The incorporation of Illumina Dragon software within the NovaSeq X is a valuable improvement over the NovaSeq 6000. The integration of streamlined data generation and our in-house bioinformatics expertise creates a highly effective approach, minimizing routine data processing and enabling more focus on delivering significant results that cater to our clients' needs." In terms of the roadmap, for Dragon Onboard NovaSeq X series, as mentioned earlier, we'll continue to invest in onboard applications. With Dragon Onboard NextSeq 1000 and 2000, our mid-throughput sequencers, we doubled the number of applications and tripled the flow cell support in over 2 years. We also added support for many different panels. And with NovaSeq X series, we'll continue to innovate to meet the needs of high-throughput customers. In fact, in Q4 2024, we plan to launch 2 new applications on board the NovaSeq X series, Dragon Somatic and Dragon Methylation, enabling cancer research and epigenetic applications. And with that, I will pass it over to Meghan. Thank you.
Thank you, Deepthi. For the NovaSeq X series portfolio, Currently, we're shipping the NovaSeq X Plus, which is our dual flow cell instrument, as well as the 10B kit. Coming this quarter in Q4, we'll begin shipping the 25B kit and the 1.5B kits. In the first half of 2024, we expect to release the NovaSeq X, which is our single flow cell instrument. The NovaSeq X has delivered in all aspects of sequencing. We've decreased cost and turnaround times while increasing output. We've made it easier than ever to use and even added onboard analysis. We've extended our commitment to sustainability by reducing packaging and waste and enabling ambient shipment. We have thousands of instruments worldwide running many types of applications on our platform. Lastly, we have an amazing service and support team dedicated to helping our customers succeed as they dream big.
Thank you, Meghan and Deepthi. This was great information. Now I would like to open it up to our Q&A session.
All right, thank you, Sarah. So we'll get started with a few questions. If you have anything pop into your mind, feel free to place them into the Q&A. So first, we'll look at, let's see. So how are libraries loaded onto different lanes? Yeah, so great question. Bringing back that beloved individually addressable lanes, but now we've made it easier than ever. So within the kit, you'll have a library strip tube, and essentially you'll just denature, dilute your pools, place them into their individual tubes in the strip tube, and then you'll just pop the strip tube into the reagent cartridge and into the sequencer. So no need for like extra consumables or like a docking station or any type of extra machinery. So everything to get the individually addressable lanes will come right with the kit. All right, Deepthi?
Great. I think I see your Dragon question. Thank you, Meghan. And I think I see a Dragon question. Let's see. Do I still need on-prem Dragon server if I already have onboard Dragon? Okay. This is such a great question. So there are a couple of scenarios where you might consider using a Dragon on-premise server to complement your onboard analysis. For instance, you may not be able to reanalyze data using Dragon onboard NovaSeq X. You cannot reanalyze data using Dragon onboard NovaSeq X. So we recommend using either a Dragon server or Dragon on cloud like Dragon on Illumina Connected Analytics for maximum flexibility. Other scenarios where you might want to use Dragon server is for greater customizability with command line access, or if the application pipelines you want to use do not exist on board. For example, metagenomics is an example of application pipelines that exist on the Dragon server but not on board NovaSeq X, or single-cell RNA for that instance. So these are some of the scenarios in which you might want to consider using Dragon on-prem server or Dragon on Illumina Cloud if you already have the onboard Dragon and that can nicely complement your onboard Dragon analysis. Thank you.
Okay, so I see another question about the price point for 25B flow cells. Yeah, so the list price for 25B, which only comes in the 300 cycle kit right now, that will be $16,000 US. So that equates to about $2 per gig, and trying to remember like 0.62 cents or something per million reads. But we could definitely follow up with the exact prices on those. But the kit price will be, like I said, $16,000, and that has the 8 terabases of data and the 26 billion reads per single flow cell. So I see another one. So for the X Plus, can I load the second run while the first run is still running, or do I have to wait till the first run is done? So great question. So currently Stagger is not enabled. So as it is right now, you would need to load both runs at the same time, but they could be, different flow cell types. So once we release the 25B and 1.5B, you will be able to kind of mix and match, load a 25B on one side and a 1.5B on the other side. I will say that adding Stagger Start is definitely on the roadmap. So kind of similar to the 6000, where we added that Stagger capability, in a slightly later software release. We're expecting something similar for this. Okay, let me take another one. So when in Q4 will the 1.5 be flow cells available to ship? So for both the 25B and 1.5B, we don't have exact release dates at this moment. For 25B, we did just open pre-orders yesterday. So hopefully, we'll be able to begin shipping those in a timely manner. And then for 1.5B, we still just kind of have the general Q4, but we should be coming out with some more definitive things in terms of dates in the next couple weeks. So definitely stay tuned and in touch with your sales team.
I think I see a question here on Dragon, which is the analysis on Dragon Onboard. Does it increase the sequencing run duration? We actually covered this in one of the slides, I think slide 34. Could we go back to that slide? If that's possible, that'd be helpful to explain. But yes, great. So with Dragon, you can actually do back-to-back sequencing. It depends on the type of analysis you're doing on board. If you see here on the slide on the left, with some of the applications like BCL Convert, Dragon RNA, Dragon Enrichment, or Dragon Germline Map and Align, you can actually do it between the wash and prep time between your runs. So this is assuming a 2-hour wash window and 1.5 hours of hands-on run setup time and 4 hours of cluster generation. So that's about 6.5 hours. And many of these analysis pipelines are shorter in duration than that, gap between the two runs that you need. So Dragon can be completed the analysis can be completed between your runs, enabling you to do back-to-back sequencing and increasing or accelerating your sequencing throughput. But now there are certain runs which are computationally intensive. For example, germline with small variant calling and germline with all variant callers that takes slightly more than your wash and prep time. I think it's about 7.5 hours when we use Illumina data, but yeah, you would expect in that range. It's not significant, but it's still slightly more than your wait time between the runs. So these are the two analysis pipelines we have identified that might take more time than your traditional, typical wash and wait time. Hopefully that answers the question. Please do feel free to put in more questions if you need more clarifications around this. And also, the Software Ecosystem Tech Note is a great resource to get all of these details. Thanks.
All right, thank you, Deepthi. So another question is, if we're using the 10B flow cell to titrate the library loading concentration, can we use the same loading concentration for the 1.5B? And so what I will say is that the library should perform generally similar between the different flow cell types, but because we have the individually addressable lanes, there will be some differences. So if we think about it this way, the 10B, if you divide it up by the 8 lanes, we should get about 1.25 million reads per lane. Compared to the 1.5, we should get about 0.8 million reads per lane. And then looking at the 25B, that's even higher at like 2.5 reads per lane. So if you think about how we end up with those differences. All that to say that there is some differences in lane size between the different flow cell types. So while libraries should perform similarly between the 3 flow cell types, just due to differences in the lane size and fluidics and kind of all of those types of dynamics, we might still have to optimize based on the different flow cells. So I would say it's definitely a good starting place to try what you found to work for the 10B. But as you go up to 25B, you might need to increase slightly, and then conversely, as you go down to 1.5B, it might just need to be tweaked a little bit more. Okay, and then let's see. Oh, about the 6K and NovaSeq X comparison data. Let me pull that up. Let me push that slide again. Just bear with me one second. Okay, so the comparisons for the 6K to NovaSeq X data. So for whole genome, you can see we have the number of samples that were assayed at the bottom, but they're all based on 120 gigapace per sample, so at just slightly over 30x coverage. And if you're interested in more of the data comparisons, I believe the resource list should have the data concordance app note. So that app note goes through 6K to X. It has whole genome, it has whole exome, it has the RNA sequencing, and I believe single cell. So we do have kind of more comparisons coming out. And then additionally, if you're interested in seeing what that looks like, on a live run, if you will, on our base-based sequence hub, under the public data section, we have a whole list of runs that are posted there that you could view, like the SAV metrics, as well as you could even run them through, some of them have projects that you can run through analyses and kind of compare it to your pipeline. But on there, we have even more. So we have a ZymoSeq methylation, we have a 10X library, and then we have kind of a lot of the standard whole genome, whole exome, bulk RNA, we have mRNA, and just those types of things. So I would definitely recommend taking a look at the concordance app note, as well as going to look at the base-based public data sets if you're interested in kind of diving deeper into those. All right, Deepthi, do you have another dragon one?
Yeah, I see one dragon one. When will Dragon 4.2 be available on board NovaSeq X? So this is a great question. Typically, the onboard applications, Dragon Onboard NovaSeq X series and Dragon Onboard any of our sequencers, it takes extensive development and validation for onboard applications. So the onboard Dragon typically gets less frequent updates compared to what's available on the Dragon server or on Illumina connected analytics or base-based sequence hub. So at this moment, we are focusing on bringing on more applications to Dragon Onboard NovaSeq X, while the core Dragon update roadmap is being actively planned. So following the release of Dragon Onboard apps, there'll likely be another release planned for 2024, which will likely bring the latest Dragon version to onboard. So stay tuned. I mean, that's what we can say for now, but for sure there are new apps coming. And then as 2024 rolls around, we'll have new updates planned. Thank you.
Okay, so I see, Deepthi, one more dragon question for you there. Do you want to take that?
Yeah, Oh yeah, I see it now. Can I load the data back to the sequencer for analysis once it's off board? So I believe I might have answered this in an earlier question, which is, when we talked about the difference between a Dragon server and needing the Dragon server if you already have the Dragon on board. So especially if you want to have, if you want to load the data back to the sequencer, that's unfortunately with Dragon on board NovaSeq X, you can only process the data that's generated on the sequencer, and that remains on the sequencer. If you take the data off the sequencer, you would need another alternative to process that data. We recommend either a Dragon server or Dragon on ICA to reanalyze that data.
All right, thank you, Deepthi. And so I see one last question in the chat. Feel free if you have any other last minute ones, but we'll go ahead and answer this last one for now. And so are the reagents stored at room temperature? How long can you leave them out? Yeah, so with the ambient ship, the reagents will arrive at room temperature. We do recommend getting those into their respective storage conditions within about 3 days. So definitely more flexibility, especially if they arrive on a Friday night or the weekend. You definitely don't have to rush in and get those put away. But their storage conditions will be, so the reagent cartridge will be in -20, the flow cell will be in 4 degrees, and then the buffer will be at room temperature. So very similar to the 6K, but I will just add as well that due to the reduced size, there is a significant savings in terms of that storage space for all of the components. So that also is a slight benefit to the reagent cartridges. Okay, so those are all the ones that I see for now. We just want to say thank you so much for joining. We're really excited for the things that are upcoming for NovaSeq X this quarter, the new Dragon apps, the launch of 25B and 1.5B in the coming weeks. So again, thank you for joining us. Reach out to your sales, your sequencing specialist if you have any questions. And yeah, have a great day. Thank you.